This question is from production for 2 marks. A cylindrical bar with 200 mm diameter is being turned with a tool having geometry 0 degrees, 9 degrees, 7 degrees, 8 degrees, 15 degrees, 30 degrees, 0.05 inch, resulting in a cutting force FC1. If the tool geometry is changed to 0 degrees, 9 degrees, 7 degrees, 8 degrees, 15 degrees, 0 degrees and 0.05 inch, and all other parameters remain unchanged, cutting force changes to FC2. Specific cutting energy in joule per mm cube is UC is equal to U0 into T1 power minus 0.4, where U0 is equal to the specific energy coefficient and T1 is the uncut thickness in mm. The value of percentage change in the cutting force FC2, that is FC2 minus FC1 by FC1 into 100 is. So for this numerical answer type question, we need to round off the answer to one decimal place, and the accepted answer range for this question is minus 5.8 to minus 5.5. We need to understand that this question is from the concepts of metal cutting. Let's move on to the solution, and first let us understand what is the tool designation according to ASA system, that is alpha B, alpha S, theta E, theta S, CE, CS, R. From this, we need to understand that alpha B is the back rake angle, alpha S is the side rake angle, theta E is the end relief angle, theta S is the side relief angle, CE is the end cutting edge angle, CS is the side cutting edge angle, and R is the nose radius. From the question, we have the geometry of the first tool designated in this way. So when we compare the geometry of this tool 1 with the standard geometry given above, we can get that CS, that is the side cutting edge angle for the first tool, is 30 degrees. Since the cylindrical bar is being turned, we need to convert this angle into the orthogonal rake system, that is lambda 1, which is the approach angle, that is equal to 90 degrees minus the side cutting edge angle of the tool 1. So that will give us 60 degrees in the orthogonal rake system. So similarly, we have the geometry for tool 2 given in this way. So when we compare this with the standard designation above, we get side cutting edge angle for tool 2 as 0 degrees. So converting that into the orthogonal rake system will get us approach angle for the second case to be 90 degrees. Okay, the specific cutting energy in the standard notation is given by UC is equal to cutting force divided by 1000 into feed into depth of cut. Let us consider that as equation 1. But in the question, we are given with the specific cutting energy expression, that is UC is equal to U0 into T1 power minus 0.4. Let us consider this as equation 2. When you look at equation 1 and equation 2, both are equal to the specific cutting energy. So equation 1 and equation 2 can be equated using the right hand sides of both these equations. So doing that will give us this expression. And from this expression, in the left hand side, let us just try to put the cutting force and send all the denominator in the left hand side to the right hand side will give us FC is equal to U0 into T1 power minus 0.4 into 1000 into feed into depth of cut. Now, it is very important to remember here that the uncut thickness can be written as feed multiplied by sine of lambda. Okay, so from this expression, we can conclude that the cutting force is directly proportional to sine of lambda power 0 minus 0.4. So using this, we can write FC2 by FC1 is equal to sine lambda 2 by sine lambda 1 whole power minus 0.4. Therefore, we need to calculate FC2 minus FC1 by FC1 into 100. That can be written as sine lambda 2 by sine lambda 1 whole power minus 0.4 minus 1 into 100. We know that lambda 2 is equal to 90 degrees and lambda 1 is equal to 60 degrees. So substituting that and simplifying will give us FC2 minus FC1 by FC1 into 100 as minus 5.6%.